Okay, so let's we're going to be looking at the cosine rule and the sine rule, and we'll also look at the we'll also be looking at the area of the triangle rule, which there's two areas of the triangle rule. There's the one which is half base times height, but we're going to be looking at the more advanced area of the triangle rule. So we've got a triangle, and this doesn't have to be. It does look like it's a right angle triangle there actually, but it may or may not. It works on all triangles, including right angle triangles. These rules. The first thing we want to do is label all the angles, and it doesn't really matter what order we label them in. So we'll just call them A, B, and C. That's let me get a thicker pen. So A, B, and C. Now, you really should be doing capital letters here. This is, otherwise the formulae won't make any sense to you when you look at your formula booklet. So the angles are capital letters, A, B, and C. Now, the opposite sides are also A, B, and C, and they are the same letters as the angles. So the opposite side to C is lowercase c, and the opposite side to A is lowercase a, and this is lowercase b. And I'm referring to the lengths of the sides there. So this is that's the first stage, and there's basically three formulae which we're going to try to understand based on the different that are using these different symbols here. So these are the formulae here. So let's look at them in turn. The sine rule is the easiest one to use once you're familiar with it. At first, these two equal signs throw people a little bit, but all it's really saying is that if I take any side and divide it by the sine of the opposite angle, that's going to be equal to any other side divided by the sine of that angle. So maybe I can copy this triangle, and instead of labeling it A, B, and C, just give it some like values. So if we said that was 20 degrees, and this was say 12 centimeters, and this was 10 centimeters. Well, it's clearly longer, isn't it? So let's make it 18 centimeters. And I wanted to work out this side here, which we'll call x. Then, as this is saying, any side divided by any angle, 12 over, divided by any sine of that angle. Okay. So yes, how the length of this side divided by the sine of that angle would be equal to the length of that side. Let's put it in centimeters, divided by the sine of x. So if I wanted to work out x in this case, I would just rearrange the formula. And we notice that if we look at this bit, the upside down will be true. Now this shouldn't be too surprising, because hopefully you know that let's use different letters. If x over y is equal to w over z, so if that, then y over x is equal to z. That's supposed to be a z over w. So this is just a mathematical rule which can be quite easily proven, but for now we're going to take it. We're just going to kind of take it as read. Okay, so I've taken the tops and I've just flipped them, haven't I? Okay, so that's why if this is true, then this is true. Okay, so rearranging this, I can maybe flip it around, and I can say, let's do the right-hand version. So sine 20 degrees divided by 12 centimeters is equal to sine of x over 18. And then I would just multiply both sides by 18. I get that. And that gives me sine x, and then I can do the inverse sine of it, and that will give me x. So that's me applying the sine rule. Let's let's look at the cosine rule. Let's look at the formula first of all, actually. So the formula looks a lot more complicated and it kind of stresses people out. They think like, how am I going to remember this? But if we study the formula in a bit of detail, so let's go any of these sides. So I could have labeled this in a different way, but any of the sides is equal to, so any of the side, and you square the side, and then you take the square of the other two sides added together, then you minus the two sides, the other two sides are not including a, multiply by the cosine of the angle opposite the side we're looking at. Okay, so if I highlight this, we should hopefully be able to see that side, which we'll use A, is there, and there's that angle A is over there. And of course, it doesn't matter which way round we add B and C, because it doesn't matter which way around we label B and C. And of course, we know that when we add two things, it doesn't matter which way around we add them. So what do we need to remember in this? Well, we take the subject of the side we're trying to work out, and then it's going to be equal to the other two added together, and then we just have to remember that this is a minus, I suppose, and that these are and to include this bit. So we've got the B and the C. Again, it doesn't matter which way around you times B and C, does it? So just try to focus on the things that you need to remember. Don't forget the minus symbol. Don't forget that the angle is the angle opposite the side we're trying to work out. So let's do an example of this one now. So we've got our triangle again. This time we will we'll just say that this is our side. So we'll call this X, and we'll say that we know this angle here is, say, 25 degrees, and we know that this side is, say, maybe 10 centimeters, and this is 16 centimeters. So X, if X would be equal to the square root of 10 squared plus 16 squared minus 10 times 16 cos, and I'm running out of space. Let me just make that a bit bigger. Times cos 25. So that's how you would apply the cosine rule there. Okay. So what about if we are trying to, because we don't always, we might need to rearrange the equation at times, right? So we might need to find the angle out, and then so hopefully you're able to then think about how to rearrange that. You just subtract b squared plus and c squared, and you have to then minus everything to turn that into a plus, and then divide it by b and c. But I won't do rearrangements of this one right now. The main thing I want to focus on is, how do I know if I want to use the cosine rule or the sine rule? So the phrase I always use is this idea of working with. Now, the reason why I use that phrase is because a lot of the time students and teachers will say, what information are you trying to find, or what information do you have? But you need to know both of those things. So take all the things that you are trying to find as well as the things you're trying to work out. Those are the things you're working with. So if we take our example down here, what are we working with? We're working with two angles. So two angles and two sides. So in other words, I don't know this side and I don't need to know this side. I don't know this angle, I don't need to know this angle. Whereas in this one over here, I'm working with one angle and three sides. I'm ignoring which one I need to know. The point is, which ones am I working with? These angles I don't know and I don't need to know. So that's how I know it's the cosine rule, because the cosine rule only contains one angle and it contains three sides. So that's how I know it's that one. The sine rule, I know it looks like it contains all three angles and all three sides, but all that's trying to say is that we can basically draw a box around make the equation with just one equal sign, and that could be an equation, or this could be an equation, or if you want, you could imagine this one next to that one, and that would be an equation. Anyway, that one's only going to have two angles on two sides, and so that's how we know to use the sine rule. So let's just have a look at the area of a triangle rule, which I thought would have come up real quick straight away. So can't see it here. I'm just going to pause the recording. Okay, so area of a triangle still use the same terminology, right? So we've got angle C, angle B, angle A. This is a little bit confusing because they've also labeled this angle theta. That's confusing because that theta is, in fact, I might edit that because where's theta in this equation? It means this is what theta would be, I guess. So we shouldn't just ignore that. Basically, that's angle C. So all it's saying is that the area of a triangle, if we don't beforehand, we need to know the height and the base, so half base times height. But if we don't know, in this case, let's say a new side, let's say a new side C, I would need to know the perpendicular distance from here to here. If I don't know that, that would be the equivalent of the height. If I didn't know that, then I can't use half base times height. However, if I just know the regular dimensions of the triangle, I can apply this rule here, and that would help me to calculate the area. So again, it's the half times the length of times the product of any two sides multiplied by the sine of the angle of the remaining side. Okay. All right, so we'll leave it there. We'll have a go, maybe have a go at some questions.